Good evening everyone. Now let's see third part or fourth video of this number theory, MCQs on number theory. So first MCQ, see, let n greater than 1 be a composite number, then there exists a prime p such that p divides and so we have proved this theorem. Yes, I have already uploaded a video on this theorem. Yes, so option 1 is the correct option, where p is less than or equal to root n. P divides n and p is less than or equal to root n. Second option is wrong, third is also wrong, and fourth is also wrong. So option 1 is the correct option. Yes. Next, for n greater than 0, the numbers of the form 2 to the power n plus 1 are called, we have already seen in class, this is called Fermat numbers. Yes, 2 to the power n plus 1 are called Fermat's number. Put n is equal to 1, n is equal to 2 and so on. You will get sequence of Fermat's number. Yes. Third MCQ, for n greater than 0, the numbers of the form mn is equal to 2 to the power n minus 1 are called Mersyn's number. Yes, 2 to the power n minus 1 are called Mersyn's number. Remember this. This is not a Fermat number. Fermat number is 2 to the power n plus 1. Okay, this is Mersyn's number. Yes, next MCQ. Any two Fermat's number are always relatively prime. We have seen these two Fermat's number are always relatively prime, or you can say co-prime. Yes, co-prime means relatively prime. Yes. MCQ number 5. Given a positive integer n, tau of n or d of n, yes, totient function or dn denotes the what? Denotes the number of positive divisors of n, not a sum of positive divisors of n. Sum of positive divisors of n is denoted by sigma of n. That is next MCQ. Yes, so answer is number of positive divisors of n, tau of n. Remember this. Yes. Next MCQ. Given a positive integer n, sigma of n denotes the what? Sum of positive divisors of n. We have already seen. Yes. Next, MCQ number 17. Tau of n is equal to, what is definition of tau of n? How to find tau of n? Tau of n means number of positive divisors of n. How can we find number of positive divisors of n? So formula is this. Yes, summation of 1 where d divides n. Yes, remember this formula. Yes, next MCQ. And formula for sigma of n, that is sum of positive divisors of n, is denoted by summation of d, where d divides n, okay. So option 1 is the correct option. What is tau of 10? How can we find tau of 10? Yes, 10 ला कोण डिवाइड करते? 10 ला डिवाइड करतो 1, 2, 5 and 10. हे 4 नंबर डिवाइड करतात, बरोबर. सो आन्सर इज 4. आपल्याला tau of n म्हणजे काय? नंबर ऑफ पॉझिटिव्ह डिवायझर्स. येस, आणि किती आहे नंबर ऑफ पॉझिटिव्ह डिवायझर्स? 1, 2, 3, 4. सो ऑप्शन इज option number 2, that is 4. Yes. Sigma of 10. What is formula of sigma of 10? आत्ताच आपण पाहिला काय आहे हे बघा, वरचं MCQ. सिग्मा ऑफ n काय आहे? समेशन d व्हेअर d डिवाइड्स n. तर सिग्मा ऑफ 10 काय काढणार? सिग्मा ऑफ 10 इथे जर आपण 10 चे पॉझिटिव्ह डिवायझर्स बघितले, 1, 2, 5 and 10, 4 डिवायझर्स आहेत, यांची फक्त ॲडिशन घ्यायची. सिग्मा ऑफ 10 कसा निघणार मग? 1 + 2 + 5 + 10. What is sum? Sum is 18. So option D is the correct option. Yes. Next MCQ. If n is equal to p1 to the power k1, p2 to the power k2 and pr to the power kr, then tau of n, number of positive divisors of n. काय आहे फॉर्म्युला? We have already learned this is the theorem. Yes, what is k1 plus 1, k2 plus 1, k3 plus 1 up to kr plus 1. Okay, we will see example on this formula. Yes, so write down this formula. Tau of n is equal to, if n is equal to like this, then we can find tau of n k1 plus 1 into k2 plus 1 into k3 plus 1 up to kr plus 1. Okay, so see, we apply now that formula. Tau of 180, we have to find number of positive divisors of 180. Number of positive divisors of 180 is equal to, so see, we can write 180. Yes, base is always prime, and we can write 180 as 2 square into 3 square into 5 to the power 1. Yes, so what is k1? K1 is 2, k2 is 2, and k3 is 1. So add 1 1 1 in k1, k2, k3 and take multiplication of these three numbers. So 2 plus 1 into 2 plus 1 into 1 plus 1. So 3 into 3 into 2, that is 18. So option 2 is the correct option. We have solved this number of positive divisors by this formula. Yes, this formula. Yes, k1 plus 1 into k2 plus 1. Write first en as in this form. Yes, understood. Next, if n is a positive integer such that sigma of n is equal to 2n, then n is called which number? 2n. So that is not a Fermat number, not Persin number. Yes, so what is perfect number? So definition of perfect number is, a number is called perfect number if sum of positive divisors of n is double to itself. Sum, yes, here sigma is sum of positive divisors. Sum of positive divisors is double to itself, is called perfect number. So answer is option 3. That is sigma of n is equal to 2n is called perfect number. Next MCQ, phi of n is equal to n minus 1 if and only if, yes, we know, if and only if n is prime. Yes, what is phi of 5? Phi of 5 is 5 minus 1. What is phi of 19? Phi of 19 is 19 minus 1. All these are prime numbers. What is phi of 7? Phi of 7 is 7 minus 1, where phi is Euler phi function. We call this as Euler's phi function. Yes, Euler's phi function. Yes. Next MCQ. P minus 1 factorial is congruent to minus 1 mod P if and only if, what? If and only if, this is Wilson's theorem. Yes, Wilson's theorem, very important theorem. If and only if P is prime, P is an odd prime. Which one is correct? P is prime is the true option. Yes, not P is an odd prime or P is an odd integer. So here P must be a prime. This is called Wilson's theorem. Wilson's theorem. Okay, Wilson's theorem. Here this is Euler phi function. Yes, if a and m both are integers, belongs to set of integer, then when we say that this is means a to the power phi of m is congruent to 1 mod m, if and only if GCD of a and m is 1. GCD of a and m is 1 if and only if GCD of a and m is 1. When we apply Euler's phi function, if GCD of a and m is 1, then we can write like this. Okay, then again next MCQ on Euler phi function. Which of the following is true? If GCD of m and n is 1, means m and n are relatively prime, then phi of mn is equal to phi of m into phi of n. Yes, so like this. See, phi of 12 is what? Phi of 3 into 4. We can write 12 as 3 into 4. So you can write phi of 3 into phi of 4. Yes, what is phi of 3? 2. And what is phi of 4? Phi of 4 is also 2. Yes, understood. So if why we are writing here phi of 3 into phi of 4, because GCD of 3 and 4 is 1. Yes, so option 1 is the correct option. Next, if m is equal to p1 to the power k1, p2 to the power k2 up to pr to the power kr, then this is the formula to find Euler phi function. Yes, then if you solve by this formula, you will get phi of 100 is equal to 40. So all above three options are correct. So option 4 is the correct option. All of these are correct. Okay. Next MCQ. See. Yes. If GCD of 135 and 225 can be expressed as a linear combination of 135m plus 225n, then find the values of m and n. So what are the values of m and n? Yes, so we have already know how to solve this such type of questions. This we can solve by Euclid's lemma. See here, we can write 225 as in terms of 135. Yes, so 225 is equal to 135 into 1 plus 90. Again we can write 135 in terms of 90. So 135 is equal to 90 into 1 plus 45. 90 is equal to 45 into 2 plus 0. So GCD of 225 and 135 is 45. Yes, so we can write GCD in terms of GCD as a linear combination of these two numbers. So 45 is equal to, reverse all these steps and you will get 45 is equal to 135 into 2 minus 225. So here m is equal to 2 and n is equal to 1. So which option is the correct option? C. M is equal to 2 and n is equal to 1. So option 1 is the correct one. Yes. Next, find the series of all positive integers when divided by 5 leaves the remainder 3. Yes, which one is the correct? When divided by 5 and leaves the remainder 3. So 5 divide by 5 and what is remainder? So here remainder does not get remainder 3. So this is the correct one. Yes, 8 minus 5 3. Yes, 13 minus 10 3. 18 minus 15 3. 23 minus 20 3. Yes, so this one is the correct series. Option 2 is the correct option. Yes, we have seen complete residue system. Yes, modulo m, complete residue system of modulo m. Yes. See, next MCQ. The linear congruences Ax is congruent to B mod n has a solution if and only if. If and only if. So we know this is the theorem when D divides B. Yes, and what is D? D is the GCD of A and n. If D divides B, then we can say that this linear congruence has a solution. Yes. Next question. Find the least residue of 2 to the power 68 is congruent to 1 mod 19. Yes, so use here Fermat's theorem because 19 is a prime number. Yes, so apply Fermat's theorem. If p is prime and p doesn't divide a, then a to the power p minus 1 is congruent to 1 mod p. 19 is prime number, hence we are applying here Fermat's theorem. And GCD of 2 and 19 is 1. Yes, so here a is equal to 2, p is equal to 19. Put values in this formula. Value of a and p put here. So you will get 2 to the power 18 is congruent to 1 mod 19. Yes, taking cube on both sides. Yes, we can take, this is the theorem of congruence. So you will get 2 to the power 54 is congruent to 1 mod 19. And again if we do power 2 to the power 6, we will get 2 to the power 6 is 64. 64 modulo 19 is 8. Yes, call this as equation 2. So after solving, we will get 2 to the power 14 is congruent to 2 to the power 14 is congruent to 13 mod 19. Multiplying equation 1 and 2. Yes, here call this as 2. Multiplying equation 1 and 2, you will get 2 to the power 54 into 2 to the power 14, that is 2 to the power 68, which is congruent to 1 into 13, that is 13 mod 19. So option 4 is the correct option. Yes. Thank you.